here's just the overview here. Exponential growth is all about growth factors. We saw that in a particular situation, there are many growth factors. There's not just the one unit growth factor, but there's other growth factors too, depending on what change in input we're talking about. So if you change the input 5 units, there's a 5-unit growth factor. It's a multiplier on the output to get the next output, 5 units of input later. Okay, so every situation has many growth factors. Each one of those growth factors has an associated percent change. Okay, so this little statement at the bottom is true no matter what growth factor you have. 1 plus the decimal version of the percent change is always equal to the corresponding growth factor. Okay? So that's review. So I want to talk about especially percent change here. So growth factors and percent change. So what's the center of it all? The 1 unit growth factor, and from our formula, that was B. Okay? So B was our main symbol for the 1 unit growth factor. Can we easily get the 3 unit growth factor if the 1 unit growth factor is B? What is it? 3 times B, right? Hopefully you said no, it's B cubed, right? So if we're going to advance 3 units, we would multiply B each time for each unit, and so you're multiplying B 3 times together to have the same effect as skipping ahead 3 input units, okay? So multiply by B cubed, the output, to get the next output 3 input units later. Make sense? So these growth factors are, if you have the 1 unit growth factor, really any growth factor is easy. So what's the 10 unit growth factor? Be the 10th, 16, be the 16th. And then on Wednesday, we talked about partial unit growth factors. How do we get the 1/2 unit growth factor? 1/2 times B, right? No, yeah, B to the 1/2. We're saying that, we're asking what? So call this, just call it, say Q. So if you multiplied Q together 2 times, it would be the same thing as B, right? If it's the 1/2 unit growth factor, then the Q times Q would be the same effect as B. So Q is B to the square root, or B to the 1/2, right? Okay, similarly, 5th unit growth factor, 8th unit growth factor, B to the 1/5, B to the 1/8, okay? So, given a growth factor, getting another growth factor in the same situation is pretty simple. You've got direct transference, directly transferable between growth factors. Okay? So that's what makes them advantageous to be the focal point of exponential growth, because we can get from one to another really easily. The question is, what about percent change? Does percent change have the same kind of transference, easy transference? So let's explore that, okay? So the 1 unit percent change, we know, is easily found for the 1 unit growth factor. Similarly, every growth factor, it's easy to get its associated percent change. And our question is now, do we have an easy transference between percent change? Okay, someone said no. So let's check it out. Let's do an example. Suppose the 1 unit growth factor is 1.25. Okay, so what's the 3 unit growth factor? What's the 3 unit growth factor if the 1 unit is 1.25? Hopefully an easy question. 1.25 cubed, which turns out to be 1.95. Okay? So what's the percent change for the 1 unit growth factor? For 1 unit change. 25, that's a nice easy one, 25%. Percent change for 3. Okay, so take a look. Is the 3 unit percent change 3 times the 1 unit percent change? No, it's not. What about, is it 25 to the 3rd? No, definitely not, right? Okay, that's 25 to the 3rd is like, what, something in the thousands. Okay, so answer to the question, do we have a direct transference with percent change? No. Percent change is not directly transferable. So the question is, so it's kind of like we got a roadmap here. If we have 1% change and we want another percent change, how can we get it? Yeah, so just stay on the road. There's roads that'll lead you from any one of these things to any other ones. The roads are the arrows, okay? You stay on the road, and it all comes back to the growth factors. It all comes back to the growth factors, the transference of the growth factors, and then get the corresponding percent change. Okay, so if the 1 unit percent change is, so here's the setup. If the 1 unit percent change is 9.2%, what's the 10 unit percent change? Okay, so what am I giving you? I'm giving you that the 1 unit percent change is 9.2%. And we are asking for the 10 unit percent change. So it's just 10 times 9.2, 92%. Oh, you're so smart. So what's the roadmap going to be here? What's it going to look like to figure out the 10 unit percent change given the 1 unit percent change? Okay, so let's just mark it off. So here we are. We're going to go first. What are you going to do first?
Change that to the growth factor.
The 1 unit growth factor, and then?
You're going to change that into the 10 unit.
10 unit growth factor, right? And then you can get the 10 unit percent change. See? Stay on the road. Stay on the road. It's all about the growth factors. Go, do it. Okay, Omar, you're up. Tell me the process. Tell me what you do first.
I add 1 to 9.2. So it would be 1.9.
1.92.
And then that's the 1 unit growth factor.
So let's look at that 1 unit growth factor. What percent increase is that right there? Is that 9.2% increase? 92. So we want 9.2.
It would be 1092.
Okay? And then you want to do with that what?
And then I want to change that into the 10 unit growth factor, so I would multiply it by itself. And 10 times that would be
Nice.
the power.
Yeah, he said he wants to multiply it by itself 10 times. I like that. I like that. He said he wanted to multiply it by itself 10 times. That's the same as to the 10th power. Okay? You're on a roll. Keep going. Then what?
Then I would get the growth factor of the 10th of the 10th.
Tell me what it is. Someone shout it out. 411? Awesome. Okay?
And then I would subtract that by 1.
Or rewrite it as, let's see, subtract 1.
And I'll multiply the change by 100 to get the percent.
And what percent is that?
1.411.
141.1% increase. Agree? Is that what you got?
141.1.
Awesome. Good. Nice. All right. Notice it's not, what do we say? It's not what? Take this times 10 and you get?
Something else.
92%. Not even close, right? Not even close. So here's a great question to ask. Why? Why isn't it 10 times 9.2%? Instead, it's this much higher value, 141%. Scott, want to give a shot?
Yeah, because multiplying it by 10 would take 9.2% of the original value 10 times instead of 9.2% of the previous exponential value.
So taking 9.2% of the first value and then repeating that increase. What kind of rate of change would that be?
Additive.
Right, and we call that constant rate of change, right? So if you just took taking 9.2% of the initial amount and then getting that amount, and then you just keep adding on that amount, that would be a 92% increase. That's not what exponential growth is about. It's about always taking 9.2% of the current value, which is growing. So your amount of increase will grow. You see? So the amount by which we increase, if we're always taking 9.2% of a greater amount, the amount of increase will grow, and then the cumulative effect of that is a much higher overall percent of increase. Okay, another practice problem. Let's do a harder one. Any questions on this? All right, this is good stuff. Here we go. If the 3-unit percent change is negative 47%, or this is decay, right? So this is decay of 47%. That's all the negative means. It means 47% decay every unit, every 3 units. What is the 1/5 unit percent change? Go. So I'm saying that this is a 47% decrease, or negative 40%, so 47% decrease, or negative 47%. I prefer an extra stop in this trip, okay? So I prefer one extra stop in this trip so you don't get confused. But go for it. See if you can get it. Okay. So Karen, did you get started? Kind of. So how'd you get started? Tell me how you got started. Okay. 53%. What is 53%? What you're keeping. Good. And you got that because? Yeah, good. What is it? Yeah, she said she found the other percent, 53%. So is it 1.53 if we're decreasing by 47%? So what do you multiply by to keep 53% of what you started with? That's what we're asking. What's the decay factor? If you want to keep 53% of what you started with, what are you going to multiply by? So close. Nicole? You don't know. Okay. Aiden? 0.53. That's what you multiply by to keep 53%. So that's our 3-unit decay factor. Did you go from there, Aiden? So where did you go from there?
Yeah, then I made that to the power of 1/5.
So 1/5. Let's go here. Let's go here. 1/3. He changed to 1/3. So here's I like this stop. I like to get the 1 unit growth factor along the way so I don't get confused. What do you get for the 1 unit? 0.81. Are we losing 81% or keeping 81% every time the input changes 1? Keeping. All right, so that's how much we keep. So how are we going to get the 1/5 unit growth factor?
Take the fifth root of 0.81.
0.81, fifth root, Fernando says. And what's that? 996. 0.96? Nine six what?
That's already around.
9.5 something?
Yeah, 0.995.
9.58?
Yeah, 5.8.
Thank you. Okay. 1/5 unit percent change. Christian, you're up. So that we get this 1/5 unit growth factor 0.958. How do I get the 1/5 unit percent change? Okay, so that's like 95.8%, and you're saying you want to get the other percent? Yeah. So what would it be? So 100 minus 95.8 is the other percent that's involved here? Is that 4.2? So what's the 1/5 unit percent change? Yeah, so you could say negative 4.2, or you could say a 4.2% decrease.
Can you write that as minus 4?
Yes, as a change, it's minus 4.2%. Or you can write it as a positive decrease. Either way. Okay, any questions on this? Yes? So maybe it's because of all the math along the way, you rounded some things differently. That's probably what happened. So you made it like rounded too much, or we might have rounded too much. That's probably the difference. Other questions? Okay, one last, actually, it's a little bit different now. So now I want to say that the 1 year percent change is 8, positive 8 increase. And I want to know what's the 6 month and the 1 month percent change. Okay, so if the 1 year percent change is 8%, what's the 6 month and the 1 month percent change? Christian Kiefer. The other Christian. Yes. No, is it not? Yeah, I'm pretty sure it is. We're good. Just you can't see that icon when I'm in Word. Thank you, though. Thanks. Christian Kiefer here. How about Troy? You're up. So 8% increase every year. Let's talk about every 6 months. How are you going to get the percent increase every 6 months?
8% increase the growth factor would be 1.08.
Nice. He's going to start with the growth factor, right? It's all about the growth factors.
And then to get the 6 months, you'll have to do 1.08 to the 1/2.
Okay?
That's half of a year.
6 months is half of a year, so he wants 1.08 to the 1/2.
And then if you want to find the, are we still sticking with this 6 month or we want to go to one?
But no, we want the percent change every 6 months.
It's going to change for 6 months. When you do the 1.08 to the half, you get 1.04.
Cool. Let's do a little, go out for a little further than that. Oh, for what? 3.9. Cool.
And that would be 4% or 3.9% increase.
Right? So this is what we talked about. Get the growth factor, transferred by the growth factor, then get the corresponding percent change. So 3.9% every 6 months. Okay? And then, who's next here? Every 1 month. Farah. Did you get every 1 month? What'd you do for that? Okay, so she started with this. Can she start with the 6 month growth factor? Sure. She can start with either one. You can start with the one year or the 6 months. She started with the 6 month. That's great. 1.039. You took it to the what? 106. Oh. 0.006. A little bit further. 3 something or 4? 4.3. Okay, percent increase every month. What would it be? What's to be the percent increase every month based on that? 0.643%. Agree? That's it. Less than 1% every month, 0.643%, then has the accumulating effect of 8% in a year. Questions? Okay, so we got that down. We got that down, and we know that's how exponential growth works. You can't take the 8% and divide by 2, because if you divide by 2, you get 4%, right? Or if you take 8 divided by 12, what do you get? Someone put 8 divided by 12. What do you get? Something different than that, right? 0.66666, not 0.643, okay? So here's the kink in the system when we come to compound interest. We're going to talk about compound interest today. So compound interest, what you do is you get this thing called the APR. So I'm going to do it down here in red. So the APR is called the annual percentage rate. And suppose the APR is 8%. And this is like when you get a car loan, right? Or some kind of loan. They say the APR, or you hear it in the commercials, APR, 5% or 2.2%. So that's not the whole story. There's more to the story. There's compounding. We have to decide how often we're going to calculate the interest, add it back in. Okay? So that's called compounding. So this first situation is kind of relates to semi-annual compounding, meaning every 6 months we're going to calculate the interest and add it back in. So what's the rate every 6 months? So what's the percentage increase every 6 months if the APR is 8? It's not 3.9. Here, with APR, you divide by 2, and that's your starting point. So with APR, 8% compounded monthly. We start with the percent increase every month, and the way we do that, semi-annually, or every 6 months, semi-annual. So every 6 months, what they do is you start with, you take the 0.08, and you divide by 2, and you get. So you're going to make 4% every month, not 3.9. But now from here on out, now we follow the rules. So now we want to find, what are you going to make in a year? So if you make 4% increase per 6 months, so this is a 4% increase per 6 months. So now, find the percent increase, the true percent increase per year. It won't be 8%. Okay? Find the true percent increase in 8%. Now by following the exponential growth rules. Find what that is. Yeah?
So you said it's 8% over the entire year, so it's 4% over the 6 months.
No. It's the 8% is the APR. It's not how much your money goes up in the year. So if there's more to it, you got compounding every 6 months. So with an 8% APR compounded every 6 months, you start with your percent increase, or the rate for 6 months, which is 8 divided by 2. 4%. Now from that, we can get what we're actually getting per year. So how do we do that? So we're going to get what we actually, yeah.
You take the 4%, you make it into your 1.04
So our 1.04 growth factor, good.
plus factors, and you just make it power 2.
And how would you do that? Oh, to the power 2, right? Because it's 2 6-month periods. And what'd you get?
1.08.
6?
1.6.
1.6.
So it's 8.16%.
So this is our true percent increase per year if you have 8% compounded semi-annually. 8.16%. That's called the APY. That's the true percent based on true exponential growth. But to get that starting percent increase of every 6 months, we kind of do what we said all along that we can't do. You take that 8%, you divide by 2. And that's our starting point. 4% increase every 6 months, which results in 8.16% every year. Okay, does it make sense? Question, Frank. No, this is because it's semi-annual, right? So if it's monthly, how are you going to get your monthly rate? No, so it's going to give you an APR, and it's going to say monthly compound. Divide by 12. See? Other questions? Nope. It'll be even better because it'll be even higher. Yeah?
I just got, what's APR?
APR is this number that's called the annual percentage rate. In order to figure out what you're really making, what you're really increasing, you also need how often they're going to compound, which means how often they're going to calculate the interest and put it back in. So this scenario was 8% APR with semi-annual compounding, meaning every 6 months we're going to calculate interest and put it back in. So you need to know what your rate is every semi-annual period, and to do that, you just split the APR up into however many periods there are in the year. So we take 8% divide by 2, because there's 2 6-month periods. Now we've got a starting point, and we follow the exponential growth rules. And so now what happens is, what we're really making is 8.16. Or that's what the true percent increase every year is, not 8%.
So if you want to make it more accurate, you find the APR of 1 month.
There's nothing inaccurate about this. I don't know what you mean.
I mean, if you want to find the accurate yearly percentage, you can find. You can also do it with monthly instead of 6 months.
They're different. It depends on the scenario. So I specified 6-month compounding or semi-annual compounding. Once I do that, this is all fixed now. Everything won't change. But now we can come along and say, okay, and this is what we're going to do. The APR is 8%. And so the APR is 8%, and we're going to do monthly compounding. So open up your book. $143. All right, so if you notice, actually on page 144, the top of page, those two questions are what we just answered. What is the annual growth factor for this account? Okay, so the annual growth factor was our 1.0816, continued from the previous page. So the answer to number 4 on the top of page 144, that's what we did right here. And then it says, what is the APY? What's the true percent increase every year? That's this, right? So we just did 4 and 5 on the top of page 144. So now I want you to do those again for monthly compounding. Okay, so you're going to answer questions 4 and 5 again, but this time for monthly compounding instead of semi-annual or 6-month compounding. And then after that, go on to part C and do 4 and 5 for daily. Okay, so find the daily growth factor, for daily compounding, find the annual growth factor, etc. Okay? Is the task clear? I'm going to take attendance. Do you know what you're doing? Any questions? Okay, so Roy can circle around and help. So you're going to do the same process for monthly and then again for daily. Same process for monthly and then for daily. Okay. Carter. Where's Carter? You're up. So did you make some progress on 8% compounded monthly? What are you going to do?
8% compounded. Which question is
That was the first thing you were going to do when I said put you to work. So you wanted to figure out what the annual growth factor is and the annual percent increase. Did you make progress on that?
I've got the 8% compounded semi-annual and the 8% compounded daily.
Oh, you want to do daily? Okay, I'll come back to you. You can do daily. So where's Zachary Wilden?
Yeah, I thought we were doing the daily.
Yeah, we all started on C.
Okay, does anyone do monthly? Something. Leah.
So we did the 0.08 and divide that by 12.
Oh, I thought you can't divide the percent by 12.
We divided it by 12 months.
Yeah. I just told you, right?
So then that comes out to 1.006 or 0.0066.
Like that?
Yeah.
Okay.
And then you add 1 to that. So it's 1.00667.
And what does that represent, that number right there? What is that number? Can you explain what that is? For which growth factor? 1 month growth factor. Is that true? Is that true growth factor on your money every month? Yeah. Yeah. This is our starting point where we've got something that's actually actual, and from this one we build all the other percents. Keep going.
So you're going to multiply that by itself 12 times, it's going to be
Okay?
And then, so that means that the APY is 8.21%.
All right, cool. Is that what you guys, other people got? All right, so what happens when you compound more often? So when we compounded just twice during the year at the 6-month marks, our result in the end was a true increase of 8.16%. But if we do it every month, our true result after the year is 8.21%. Yeah, so right, if you're gonna do this, you're gonna take that 8% and you're gonna split it exactly the same over your compounding periods. What's gonna be better then? More compounding is going to be better. It depends if it's a loan or an investment. Okay, so if it's an investment, the more often you compound, the smaller rates, you're going to get what we talked about earlier, this compounding effect. So it's better if you split it up first in 12 months and then calculate your interest every month than if you did it every 6 months. All right, so lots of you, let's see here. Carter, you wanted to do daily.
Sure. So are they saying 8% that's compounded every day?
Yep.
So for the first one, the daily growth factor is 1.08.
Is that our daily growth factor? Yeah, so you're always going to be given the APR, which is this number that you need the compounding also to be able to figure out actually how the money's going to grow. So how do we get the daily growth factor? You want to try?
0.08 divided by 365.
Yeah, so you're going to take that 8% or 0.08 and start by slicing it up into 365 equal changes, okay? And is it okay if I just leave it as that fraction? Okay, let's just leave it as that fraction. And what are you going to do with that? Oh, add 1 to it, sorry. Is that the daily growth factor?
Yeah.
And what are we going to do the daily growth factor to get? And we get 3, 2. Which means 8.32. Again, compound more often, the cumulative effect is a little bit better. Okay, so now I want to know, I'm going to start off the year with $12,500. How much will I have at the end of the year? If it's 8% compounded daily, how much will I have at the end of the year? What do I do? Tell me.
You multiply that by 1 plus, since you're
Multiply it by what?
the daily amount, so 12,500 times 1.0832.
Yeah, so if this is the annual growth factor, what kind of number is it? What does it do? What is it? What is that if it's a growth factor? It's a multiplier. What multiplier is it? It's a multiplier on your money to give you new output, new amount of money, 1 year later. So it's like taking this 12,500 and we're going to multiply it by the 1 year growth factor, which we got this way. So look, it's all there. We started with what? The APR. And first we needed the daily rate. The daily rate, you just divide by 365. This is the one time it's different, right? In all of exponential growth, you're given an APR and daily compounding, you do divide by 365. It's the only time you do it. Now we have the true daily increase. Now we want the true daily growth factor. We add one, right? We got the daily growth factor. Now we want the annual growth factor. So we multiply it together 365 times. What is the annual growth factor? It's the multiplier on the output to give us the next output. So we multiply it on, in this case, output is how much money is in our account. And it gives us how much money is in the account in a year. And you got? 540?
Yes.
Cool. Okay, so on Monday, we'll pick it up here. So we know everything means there. We know what everything in that formula, what we did there, we know what it all means. I will post the next written homework soon. It will not be due Monday. Maybe Wednesday. Yeah, not Monday, but it will be posted before the weekend. It's different. Because then you're taking 8%, you're dividing it up in how many pieces? Infinite, right? So we can't really do that. Yeah, you just remember that, right? Yeah, so the harder thing is how do we get to that formula from this one? Because you can't really divide by infinity, right? And then raise it to the infinity. No, it's not about logs. It's about limits. It's about limits. Hi, G.
I had a couple problems on the